So in drawing this ray diagram, we need to consider first the scale which we are going to use. It's very important. A ray diagram, it has always the principal axis, let me put it here. Then it also has the mirror. So the mirror is denoted by a straight line perpendicular to the principal axis. That's the mirror. The next is you need to measure. In the exam, you're going to use a spade centimeter run. Make sure you measure the exact number is given. So we have first, the first thing that we must measure is the focal length, which is 2 centimeters. So I'm just approximating here that my 2 centimeters is here. Okay, that means even the other side, I must have my 2 centimeters almost somewhere there. Must be the same. Then the next thing is the position of the object. They are saying is 3 centimeters. So if this is 2 centimeters, 3 centimeters, or let me say here 4, even this side 4. So 3 centimeters must be half here. This is where the object is. So 3 centimeters there. So I'm going to show this object by arrow. Now the height of the object is 2 meters. It was supposed to be 2 centimeters, sorry. So I'll say 2 centimeters, the height of the object. Let me do this as the height of the object. Then once you do this, remember to label this. So this is a mirror. So mirror. Or this is F. F is for focal. Okay. And this is 2F. 2F. Then this is also F. This is also 2F. Once you do this, then you need to draw a line from the top of the arrow there, perpendicular to the principal axis until it meets the ruler, the mirror. Then bend it until it passes another focal point on the other side, and leave it. Then the second line you draw is also from the top of the arrow, but it passes through the optical center there. Okay, like that. Then that means your image will be here. Now your image is already shown by a downward arrow or just dotted lines to show that it's opposite, it's upside down from the object. So this is the object, let me say O. This is the image, let me say I. Let me say I. So really the height of the image depends where the object has been placed. If it's placed further away from the focal length, the more, just like that, the image size is either reduces or increases. So you must know when it's placed between the focal point, the optical center here and the focal point here, what height of the image, what height do you get? Discover that you get something very large. The further away it is from this side, the more the image becomes smaller and turns upside, and turns the other side, becomes same side as the object, and those are what we call virtual images. So this is how we are supposed to answer part 1. Part B says find the magnification of the image. Now magnification, what you must know is magnification is equal to image height or image length divided by object height or object length. Now here you only pick one thing. Don't use both image height and everything. No, pick only one. So that's the magnification. So in this case, we have the object length, let me call object length, sorry, or height. Let me say object height. Object height, we had 2 centimeters. From the image height, we need to measure. Now, if this is 2 centimeters, she's almost there. So this can be almost 4 centimeters. Almost 4 centimeters high. Therefore, we say magnification MAG. Remember to write up here, I'm just abbreviating, but you in the exam, write the complete magnification word is equal to 4 centimeters divided by 2 centimeters. And magnification will give me 2x. Magnification has got no units. You can see that these centimeters, there's 4 centimeters, and there's also another 2 centimeters here. So this centimeter and this centimeter cancel. So now 2 into 4 is 2. And x shows how many times the image has been multiplied by, or how many times the image has been enlarged by a certain factor, and that factor is 2.